second type, that is the method overriding, also called runtime polymorphism. Okay, so what is the definition? Method overriding means subclass provide a specific implementation of a method that is already defined in the superclass. I already explained this. Let's see the example. Okay, before that, let's see these rules. Must have same method name and signature. So method name and the signature should be same. So the parameters should be same. Everything should be same, right? In both parent as well as in the child class, right? The second thing is must be inherited from the superclass. So we inherited this, right? Only non-static, non-final methods can be overridden, right? And access modifier can't be more restrictive. Let's see the example. We are having this animal class, right? This is what? Parent class, right? And then we are having dog class, which is extending the animal class. This is the child class, right? We are having the same method, sound. Here we are printing animal makes a sound. Here we are printing dog's bark. Implementation changed and the child class, right? Implementation changed. Now one more method is there, that is cat. Sorry, not method, class is there, that is cat. Again child, this is first child, this is second child, got it? And it says meow, right? Let's move to the main function. Main function, what we are doing? We are making the object of dog and cat using the reference of animal, right? So using the reference of animal, that is the parent class, animal A2, we are making new dog, the object of dog, new cat, the object of cat, right? So now here this part is the compile time, okay, and which object it is making? This is the part of runtime. Runtime, which object are we making? Got it? And then what we are doing? A1 dot sound, okay, we are calling the sound method of A1. Now at the compile time it will check if A1, that is the animal, is having sound or not. It's having, right? It's having the sound. If sound is not there, let's say it's not there, then it will throw the compile time error. For now it's there, so it will call the A1 dot sound. Now which method are we calling? Are we calling this animal sound or this dog sound? We are calling dog sound. Why? Because we have made the object of dog, and this is decided at the time of runtime, right? Dog is called, you know, you are getting the difference. Like at the compile time it will only check if animal is having sound or not, right? It is not checking for the dog. But at the runtime it will create the object of this dog and it will call the method of this dog at the runtime. This is decided at the runtime. Same with the cat, decided at runtime, cat is called. So it's clear for everyone, right? So this is what compile time and the runtime. That's it. Now why method overloading is runtime polymorphism? What is happening here? When you override a method and the subclass, call it using the parent class reference, right? Here we are calling it using the parent class reference. So what is happening? The actual object decide at the runtime, right? We have seen this part is executed at the runtime, so this also is executed at the runtime, right? Same example is there. Now there is one term upcasting, right? We are doing this, this is what? This is upcasting. We will see this terms, upcasting and downcasting. Before this, let's see this point. Okay, so this is clear, right? The code is clear for everyone. The method is resolved at the runtime based on the object type, not the reference type, as we have seen in the above example. Why runtime? A declared as animal, but it holds the dog object. Runtime. The decision to call dog sound instead of animal is made by the JVM at runtime, not at the compile time. At the compile time, it will check if the sound is present in the animal or not. This is called dynamic method dispatch. We are deciding which method to call at the runtime, right? This is dynamic method dispatch. Now, what are the benefits? Enable dynamic method binding and increase the flexibility, reusability. Open close principle. We have seen this yesterday, right? What was that? Open means open to extension, right? And close means close to modification, right? What we are doing here, see, this is important. In the example, what we are doing here, let's say here we are having this class animal, right? And we are taking the reference of the animal class and making new objects, right? In the future, let's say we are having one more animal, let's say what, monkey. Okay, now we will make the class of this monkey and simply call the method in the main method. We are not changing in the animal class. So here we are following open and close principle. That means open to extension, we added this monkey class. Close to modification, we are not modifying this animal class, right? So now our compile time, that is the overloading, and runtime, that is overriding, is completed.